In this lecture, we will talk about logical agents, also known as knowledge-based agents. These are agents that can represent the world with some formal representations and make inference to drive in your presentations. It also can decide what to do based on the representations of the world. Let's start with this compelling definition from John McCarthy in his article Concept of Logical AI, published in 2000. So, the idea of logical AI is that an agent can represent, so there is some representations of what? Of the world, of the goals, and the current situation by sentences in the logic, and decide what to do by inferring that a certain action or course of action is appropriate to achieve the goal. So we have here some representation, some sentences in logic of the word, of the actions, of the percepts, and also some inference about what to do based on the observations and the current situations of the world. So I found this like a very good definition of what's logical AI that actually uses the key component of what's logical AI, knowledge of presentations and inference. To put things back in context, let's review Percy Leong's diagram for level of AI intelligent systems. So we have an x-axis and we classified roughly intelligent systems into reflex-based agents, state-based agents, variable-based agents, and logical-based agents. In the previous section, we got to see many of them. So we most recently talked about the learning agents in which an agent can learn from past experience. We also saw search agent in which an agent can represent the world with states and each state has a black box that does not have any further information. We also visited CSPs, constraint satisfaction problems, where a state is represented by an assignment of value to variables. So with CSPs, we started looking into our designing agent that can actually have representation of the world and representations of the algorithm completely different. So we started separating the domain from the algorithm. So we saw for CSPs, for example, that we can formalize the problem and then use any kind of solver. So defining the program is a part of the domain knowledge. Let's embedding the domain knowledge in some representations. Then inference could be done with any known inference algorithm or learning algorithm. We developed logical agents as a class of agents that can combine information that they embed in journal in some sort of data base called knowledge base. So this information is being told to them and they can use it to make inference and adopt to new environments. So we are talking about logical agents. which is on the high level of intelligence on the x axis. So, the key concept here is really the concept of knowledge, which is information about the world that allow the agent to choose a good action or decision. So, knowledge is what is a set of sentences. The set of sentences is expressed in some knowledge representation or some language. It has to be formal to avoid any ambiguity. So, knowledge is a set of sentences about the world. A sentence is what? Is an assertion or actually a proposition about the world. A logical agent or knowledge based agent is composed of two elements, and these are knowledge base and inference mechanism. So we represent that with the database. So we have some knowledge based that is actually represented by a set of sentences in some formal representations or language. And this is completely domain specific, which means that this will depend a lot on the domain to define what are the sentences that are relevant for the intelligent systems or agents. We also have a set of algorithms that can help us make inference, and these are actually completely independent of the domain. So we have algorithms from artificial intelligence. These could be search algorithms or CSP algorithms or inference algorithms that help us actually drive new sentences from existing sentences. Given some new percepts to decide what to do, so we have algorithms, and this is our actually domain independent. And these two components actually interact, of course, and as the agent is evolving in the environment, learning from the environment and making decisions, this happens through inference. And then this inference can lead to new sentences that are being added to the domain knowledge called knowledge base. Given these two elements, a knowledge based agent should be able to represent the states, the action, incorporate the percepts, update the internal representation of the word, and even deduce or infer hidden properties of the word. And finally, the goal is to deduce the appropriate action for the agents. So, this kind of approach is called declarative approach, in which we build an agent by giving it information, and this information is through adding new sentences in some representation. This is through the procedure tell the agent what it needs to know. Initially we have some domain knowledge, and we could translate that into sentences that we feed into the knowledge base, and then as the agent interacts with the environment, it can build its own sentences and enrich that database. And the second is to create what is known. This is through the procedure ask itself what to do, so the answer comes from the follow from knowledge base through inference and deduction, in general logical deduction. So here is the knowledge based agents function that actually has an input, the percepts and returns an action. It is also maintains a database on knowledge base called KB and a counter to indicate time. All right, so the intelligent agent here does three things. And the first one is to actually translate the percepts into a sentence and tell that to the database or to the knowledge base. So this would be through translating, making to percept sentences from the percept and tell the database that this is so what I got. Okay. The second one is to decide what to do. So the agent will ask or query the knowledge base. Given the new percepts and the prior knowledge about the environment, what kind of action it needs to take. So this would be where actually the agent would be deliberating and making inference about what to do. The third component is tell the database what action the agent choose. So from the program of the agents we have and from the prior knowledge and from the new percept we have some decision about what action to take and this will be added to the knowledge base, right? So the process will repeat as times goes on. This is the general structure of the agent. We might think that actually this looks very similar to a black box model or state box based model, such as searching from how to go from point A to point B. All right, so we in this case, the agent was just searching, and it seems like here we have functions like tell and ask and make percepts. So it seems atomic, and the fact that it is not. Basically, for agents to go from point A to point B, it does not use any domain knowledge. However, if an agent knows that to go from A to B, it can use bridge 1 or bridge 2. This information could be leveraged by the agent to find the best routing or find the route from A to B. So this element that we have here actually more granular than what it appears in the algorithm.